of acid, this is bitter in taste. So a base is defined, or a substance which is bitter in taste. Now the point is, what are the objectives of a base? That means how you can identify a base. What is the identification features of a base? Okay, so as I told you that it is the opposite format of an acid, where acid turns the blue litmus in red. That's in base it is just opposite, red litmus paper into blue. That means if you soluble in an water, soluble in base a red litmus, then it convert into blue. This is the first and important features of a base. Okay, so if I going to the second part, that is a base provides an hydroxide ions in aqueous solution. In acid, you can see that this is the in the acid portion, as it is the opposite format of acid. In acid, it is the hydrogen. This is the hydroxide ion in an aqueous solution, which you can see over here. Okay, so definitely in aqueous solution, I have already told that the base, obviously OH or hydroxide ion in an aqueous solution provides hydroxide ion in an aqueous solution. So in acid, it's give H plus, and base which is give OH minus. Okay, so the third objective is the base always accept proton as per the Brotest and Lowry concept. I already told acid is nothing but acid donate proton. That means acid donate proton. This is called acid, which is donate, but it's just opposite. A base accept proton. A base always accept proton. As per the Brotest and Lowry concept, a base always accept proton. Now the fourth point is it's accept proton and donate electrons as per the Lewis theory. So the base bond definitely donates. That means it gives electron. That's why it's plus. The structure of this way is as such way. A structure of a base in such way. Definitely it's plus, because it's donate the electron. That's why it's giving the plus positive value. And the proton and neutron has been given in such structure which are acceptable in nature, and the electron are donate or release from a base. Okay, so that are the objectives. The number 5 objectives is, which is very important, that every oxides and hydroxide of metal are called bases. Okay, so what is the oxide? First of all, we have to know that what is the oxide. What kind of things is called the oxide? We basically called oxide for those metals, for those things in which the oxygen has been present, like CaO. Oxygen has been present. Hydroxide, which is the hydroxide? CaOH twice. This is calcium hydroxide, in which OH bond are present. In CaO also O bond are present. So this is called oxide bond, this is called oxide, and this is called hydroxide. So both this CaCO2 in both, not only CaCO2 and another in any kind of acid in which oxygen and hydroxyl bond are present of metals, this is called base. So that is my point. Okay, that every oxide and hydroxide of metals, keep that thing in mind. Remember, metals, not not any solid or any liquids. Every oxide or hydroxide bond of metals only, this is we can call base. Okay, for example, MaOH2 magnesium hydroxide, you know that, MgOH, in which also oxygen and hydrogen bond are present, and magnesium is also a metal. So that's why we can easily say that magnesium is a base, magnesium hydroxide is a base, we can say, as magnesium is metal and OH bond are present. Due to the two quality, number one is hydroxide portion has been present and magnesium is metal, we can say that it is base. Okay, so the next, the important features of base, which is a base always water soluble base. Some base are called metal, we already told that some base are metals, some are solid, as well as some are liquid. Okay, some base which are water soluble base, that means which are immersed or ionized in water, so they are called alkali. Okay, the water base which are the water soluble base are called in physics language is alkali. Okay, so what are the example of alkali? Suppose NaOH. So students, I think all are know that what is the full form of NaOH. This is sodium hydroxide. Okay, in sodium hydroxide, you can notice one thing, that this sodium hydroxide is fully ionized in water, as well as its water soluble base. So we definitely can say that NaOH is a alkali. Okay, similarly KOH, which is called potassium hydroxide, this is also water soluble, this is also water soluble base. So both NaOH and KOH, both NaOH and KOH are called alkali, as both are water soluble. Okay, so the last but not the least, the last important objectives of a base is very important, that all the alkalis are bases, but all bases are not alkalis. Okay, so this is the very important question, that all the alkalis in physics, all the alkalis are base, but all bases are not alkalis. Definitely. Suppose NaOH, this is why this is called alkali, because it's water soluble base. Okay, so definitely the one which is alkali, it's a base, is have to be a base, that means all alkali has to be a base. Okay, but all the base, we cannot say an alkali, we cannot say, because all the bases are not soluble in water. Okay, only some specific bases like NaOH, NaOH and KOH, they are water soluble, but all the bases are not water soluble. So why we can say, why we can say the so basically all bases are not soluble in water. So if you a question has been asked, so MgO, that is magnesium oxide. So a magnesium definitely not be able to soluble in water, but due to the presence of oxygen bond, we can say that MgO is a base. Okay, so this is a base, but not an alkali. Okay, I think you understand or you got my point. Okay, so similarly as acid, now I am going to discuss the classification of bases. What are the bases which has been classified? Okay, so there are lots of bases which are classified on strength basis, on different proforma basis. Okay, so I this all features, these all objectives of bases, I again repeat that first of all, it turns red litmus paper into blue, gives hydrogen ion in aqueous solution. Okay, can accept proton, can donate electron. Every oxide and hydroxide of metals are bases which I have already discussed as an example, and water soluble bases. And the very important but not the least, all alkalis are bases, but all bases are not alkalis. Okay, I give you or demonstrate as an example. Now I am come to the main point, which is the classification of bases, which is, yeah, now a base has been classified on strength basis. Basis of a strength, a basis of a strength or basis of a bond of an base, we can classify it. Okay, so come to the main point. On basis of classification, the first type is called strong base, and the second one is called weak base. Okay, so what is the strong base? The strong base is nothing but it's just opposite of acid. This is partially water soluble, partially ionized in water and having also some strongest chemical bond. So what are the example of strong base? The example of strong base is NaOH. Sorry, NaOH. That means sodium hydroxide, in which you can see OH bond are present. That's why it's called base, which I have already told you. So sodium hydroxide is a strong base. Okay. Similarly, the another example of KOH, which is also an example of a strong base. That means the basis has been a chemically strong bond as well as partially ionized in water. This is called the strong base. Similarly, what is called weak base? What is called weak base? Definitely fully ionized in water and having the weak chemical bond, which are called weak base. Okay, so if I going to discuss some example, that what are the example of weak base? The first example of weak base is NH4OH. NaH4H. So how you can represent NaH4OH in a chemical form? Okay, so H N N, N, E. So four. Sorry. The middle portion of this is the chemical structure of Na4OH. Okay, oxidized bond and hydrogen. So a four hydrogen, you can see four hydrogen, one, two, three, four, and this hydrogen is are placed over here. This is the chemical form of Na4OH. So the name of the chemical 4OH is ammonium hydroxide. Na4OH. This is ammonium hydroxide. This is a weak base. Okay, this is an example of weak base. Another example of weak base is FeOH3. Okay, FeOH3. This is ferric hydroxide. This is also another example of weak base. So they both the bases are fully ionized in water, as well as they are having some chemical bond are little bit weak rather than a strong base, like NaOH, sodium hydroxide, KOH, potassium hydroxide. Okay, so this is very simple part. You can easily now, I think we can easily understand strong base and weak base. Okay, so apart from this classification, if I classified bases on basis of hydroxide ion, okay, or the acidity of base, then then it also be utilized. First of all, the class, and apart from strong base and weak base, the base also has been classified in the number of removable hydrogen ion. This is very important question. Okay, as we can know that base is nothing but OH bond in which oxygen or hydrogen bond has been present is called base. So basis of this oxygen and hydrogen bond or hydroxide ion, the base also has been classified, also has been objective. So number of removable oxygen OH or hydroxide ion from a base is called acidity of a base. So a base can be an acid. A base can be a form of acidity as per some certain situation. In which situation a acidity of base can be classified? Definitely, I will explain that. What is acidity of base? First of all, I'm going to explain that what is acidity of base. What is the acidity of base? What is the acidity of base? This only depends nothing but the number of removable of hydroxide ion is called the number of removable hydroxide ion from a base is called the acidity of a base. So the number of OH, basically in a base, the number of OH is called the acidity of a base. Now my point is that what are the types of acidity base? There are lots of acidity base, lots of acidity of a base. First of all is acidity. Suppose in acidity of base, suppose I define that acidity of NaOH. Okay, what is the acidity of NaOH? NaOH, in which you can see OH bond are present and the base of OH bond is 1. So definitely, as the acidity of base is the number of OH hydroxide ion, that's why the acidity of base is 1. Acidity of base is 1. Okay. Now, suppose another example is CaOH2, in which you can see that this base having OH bond of 2. That means definitely the acidity of this base is 2. Okay. So this is the acidity, the number of acidity base of calcium hydroxide is 2. The number of acidity base of sodium hydroxide, which is 1. You can see over here. Acidity of NaOH is 1 cause OH1 hydroxide ion removed from NaOH, as I have told, or as I explained. Okay. Similarly, acidity of CaOH is 2 hydroxide ion has been removed from CaOH twice. Okay. Now you know that classification of bases, strong and weak, as well as you can know that what is the acidity of a base. This is nothing but the number of hydrogen hydroxide ion which is present in a base. This is very simple. Okay. So after that, I will come to my next topic. Okay. That what is pH? This is nothing but a scale. It's a level. It's a level or dimension of. It's a level or dimension. pH is nothing but a scale. The full form of pH is called power of hydrogen. Okay. So the full form of pH is power of hydrogen. Okay. So it is nothing but used as a scale in chemistry. Okay. So what is the definition of pH scale? How we can define pH? pH scale in a solution is the negative logarithm of the concentration of hydrogen ions in a mole per liter. Okay. So what is pH scale? You can define as it's little bit complicated to define as a pH scale. I know that, but in simple way, you just remember one thing. This is nothing but a solution. Okay, in which the negative logarithm, that means the value of pH may be negative of the concentration of hydrogen ion. That means in a base, in a solution, in a base, if the hydrogen ion has been negative value, then this concentration of hydrogen ions are soluble. Our solution is called pH scale. The unit of pH scale is mole per liter. Okay. So in this particular portion of definition, if I explain in a mathematical format, this is this way. This is this structure, in which pH is minus log or the minus value of hydrogen bond. This is called the pH scale. The value of pH scale has been calculated, has been determined in such strategies. Okay. So now the point is, what is the pH scale? How can I define? What are the value? Definitely I will explain that what are the level or value of pH in our chemistry part. So the level or dimension of pH in such a way. Okay, the scale, suppose a scale, as it is a scale, there has been a number like 1 2 3 4 5 6 7. Suppose it's a pH scale. There is a as it is a scale, there has been a lots of numbers are available over here. Okay, so if I define, if the scale, if it is a pH scale, suppose it is a pH scale which is starting from point 1 and ending to point 10. Okay, suppose this is the scale, pH scale, which is starting from point 1, which is starting from point 1 and ending to point 10. Suppose you assume that. Okay, so in this question, the level of 7, you know, under the level of 7 is called the neutral portion of pH. This is called the neutral portion of pH. Very important point. That means in your exam, suppose the question has been asked, then what is the neutral point or the neutral portion of a pH, neutral dimension of a pH, then this is definitely B7. Okay, so a question has been arising in your mind that if the value are, suppose if the value of pH like 2 3 or any value which is less than 7, then if the pH value is less than 7, then it is called acid. If the value of pH, that means if the value of any kind of thing, the value is less than 7, then it is called acid. As I dictate over here, just look this point. If the value of pH scale is less than 7, then this solution is going to be an acid solution. Okay. Now definitely you can understand that all kind of acid like you know, sulfuric acid or hydrochloric acid, all having the level of pH definitely less than 7. You can understand. Okay, so if the 7 is the neutral portion of an pH scale, then definitely less than of 7 value like 1 2 3 4 5 6, all this from 1 to 6 or any kind of decimal figure, all are defined as acid. Okay, now if the value is greater than 7, if the value is has come greater than 7 like 8 9, okay, 10 or whatever, greater than 7, if the value is greater than 7 like 8 9 10, then definitely it's called base. Then definitely the solution is called base. Suppose, just look at this point. If the level of pH is greater than 7, then the solution is called base. You can see over here. This is called base. Okay. So definitely you can understand that you can easily get the point that what are the base, what are defined base. Suppose NaOH, KOH, which I have already told, they have the pH value, they have the pH value, which is definitely greater than 7. Supposed to be 8, 9, or 9.7, or whatever, or 10. Okay, so definitely a base, the value of a base is definitely greater than 7. Similarly, the value of acid is definitely less than 7. Like H2SO4, HCl, or whatever the acid has been sustained in our universe, all are all our value are less than 7. Okay, and the portion of 7, suppose if the 7, if a solution having the uh, pH value 7, if the solution having the pH value of 7, then we cannot say that it is base, we cannot say that it is acid. This is the combination of acid and base. This is a neutral. This is a neutral situation. Okay. So come to the C point. If the pH scale is 7, then the solution is neutral. So from this pH situation, from this, I think all are understand. From this, the definition of pH, I think you understand, and as well as from this pH structure, you also know from the value of the pH, you also know that which is called acid, which is called base, and which is called neutral, which is called neutral situation. They all has been determined on the basis of the value of pH, the value of power of hydrogen. Okay, the different uses of suppose an example, the pH of our blood is 7.4. As I have told already you that if it is a scale from 1 to 20, if it is a pH scale, suppose, then the middle point is 7. The neutral point of pH is 7. Okay, and our blood, pH of our blood, the value of pH of our blood is 7.4. That means suppose in this question, so you can say if it's greater than 7, this is called base. If it is less than 7, that's why it's called acid. So as the value of 7 point frame, it's nothing acid. No one can say it is acid, no one can say it is base. It's almost a neutral portion, almost 7, but due to the fraction figure like 0.4, 0.4 value has been increased in the base way, so it is called little bit of base. That means it is slight base. Okay, so that means our blood is the combination, is the mixture or the solution of acid as well as base. It is more or less neutral. It is more or less neutral of pH value. Okay, but due to the point 0.4 fraction, it's being called base due to the 0.4 fraction, but slight base. So pH of our blood, value of pH of our blood is 7.4, but it's generally not confirm all the it's vary, but it's vary as per the ages. Nominal the age nominal the value of pH are in a range of 7.0 to 7.8. Okay, nominally this is the rate. Now it is sometimes it's varied. Suppose a child or a boy having a pH of 7.3 or a old person having the pH of 7.6. It may vary. So that's why it's taking an average figure like 7.4 is the average pH of our blood. Okay. So similarly, another example, pH of milk. If I found out the pH of milk, this is 6.4. Now the important thing is that pH is 7 is neutral, it's 6.4. Then definitely a milk is an acid, you can say, because it's the value of pH is less than the value of pH is less than 7. It's 6.4. So definitely it's less than 7. That's why it's called acid. Definitely that means milk is never milk is going to be a base. It's always be acid. Just take the trick in your mind there. Why it's happened? Because from a milk, curd is manufactured. You all know curd has been produced from a milk, and the curd is nothing but lactic acid. So definitely a milk be an acid. You can understand my point. So the value of pH is definitely be 6.4 because it is acid. Okay, you got my point. So different uses of different bases. Like I have already told you that the uses of acid. Similarly, I am going to tell now what are the uses of bases. The number one is MaOH2, magnesium hydroxide. This is called milk of magnesia. In chemical name, this is called milk of magnesia, which is used to control the pH levels and the normal digestion system of our body. Okay. Magnesium hydroxide. From this figure, you can see that this figure is called milk of magnesia. This is called milk of magnesia. Okay. This base is basically used to control the pH levels. Suppose in our body, now I am explaining, suppose in our body, if the pH level has been false, then what happens? Then definitely our uric acid of our body has been increased. So when it happens especially the time of little take of water or some heavy sunrise, that at that time our body has been going to dehydrate. So when our body is going to dehydrate, to make our body in hydrate position, we basically used saline as a water. So to control the pH levels as well as to control our digestive systems, we are used milk of magnesia as a base or as a component for our body at those moments. So to control the pH levels, when the pH level falls, the acid will release in our body. So that's why the metabolism has not been used properly, and the digestive system has going to be unproportional way, unsystematic way. To control this pH level in a neutral position as well as to maintain the proper digestive system, we basically use magnesium hydroxide, which is called MgOH2, milk of magnesia, the chemical name. So this is the one important use of bases. Okay, another important example or another important uses of bases is Ca phosphate, that means calcium phosphate. So why we used calcium? When we used calcium, I think all are know that calcium is basically used to solve the problem in teeth. It's basically used to solve the problem in our teeth. Okay, so when the calcium phosphate has been consumed in our body, the problem of our teeth, especially the problem in our teeth, the cavity power of the cavity has been decreased. So when we consume the calcium phosphate, our teeth cavity of our teeth has going to be stronger and more effective, and we get the power in our teeth. So to maintain the teeth in a proper way, we definitely consume the calcium phosphate, which is a very important base. Okay, to saving the teeth problem and stronger the cavity, we definitely use the calcium phosphate. Okay, so this is the another use or another use of calcium phosphate. That the important, now I'm going to the important part, that calcium phosphate is the hardest substance of our body. So body and the tooth is being making that portion of the tooth is consist of enamel. In our tooth, the strongest part is called enamel, which is made or which is produced by calcium phosphate. Okay, so this enamel is the hardest part of our body. This is the hardest part or strong part of our body. That's why as the enamel in teeth are making from uh, calcium phosphate, that's why the calcium phosphate is called the hardest part of our body. Okay,